But what's really confounding companies is really the edge today. And the reason why is, as you can see, there are billions of devices which are there for improving productivity, but also creating complex IT-related situations. So in this environment, it's really important that everybody understand that software can provide a very important role in organizing this infrastructure and enabling people to take advantage of all three layers. The cloud in and of itself has its complexities. Fog has its complexities, as well as edge computing devices, just by sheer number, but also individually as challenging electronic devices and electric devices. Software can provide a very important solution for companies as well as consultants and system integrators. And in the next slide, we'll see one example of that. So content delivery networks are something that have been talked about for many years and have been evolving equally for many years. It's a geographically distributed network which has been created as a result of proxy servers and the decentralized data centers. And so the goal of these content delivery networks is high availability and performance for editors and writers and people who synthesize content. In this example, we have an office in Santa Monica where a lot of this content development is occurring. And we also have headquarters in Seattle where books are published, and these are ebooks as well as physical books. And for a company to be able to tap in to the talent that's in San Francisco and the publishing capabilities in its headquarters, a content delivery network is a very effective way of distributing functions and capabilities right down to the user level and distributing back through the network finished product so that it can then be published and distributed. This is a good example of an edge computing application, which occurs in Santa Monica, and the use of the cloud, which unites the Santa Monica office with headquarters. Next. And then we know of another example where smart manufacturing, which has been a term that's been around for probably 30 or 40 or more years, involves the optimization of manufacturing processes and the utilization of internet-connected machinery and devices so that production processes can be optimized. And so this optimizing is the next generation and realization of the combination of distributed data and new world machines like robots and excellent displays and new world chemistry and sensors and people who are highly trained to utilize this. And simultaneously, while it looks like there's a manufacturing plant in some distant location, ultimately it's connected to the data center. And ultimately there are people who are using this data for manufacturing in other locations outside of the data center and the manufacturing location. And in order to get this data, connected devices sense, identify, process, and network, and use all kinds of data analytics in the process to improve manufacturing performance. And ultimately, the automation of these applications are accomplished through manufacturing equipment and asset management and control situations. And so that the smart manufacturing plants of today are a big array of smart devices in combination with data and infrastructure. Next, Andy. So considering those two examples, one of the content delivery network and the other of a smart manufacturing environment, it is very clear that there are lots of deployment challenges. And considering those deployment challenges, and first and foremost is the issue of complexity. When you're mixing humans with devices, you get complexity. When you mix various levels of infrastructure, cloud, fog, and devices, you get complexity. And when you look at those devices and the capability, increasingly condensed capabilities of those devices, you get complexity. So complexity is one thing that you need to tackle, one challenge you need to tackle in getting these deployment rights. But in addition, you've got to start off with a project roadmap, and along the way consider cloud combinations, last mile end user requirements. You've got to consider the difficulties in the volume of data and the velocity of data. A lot of people run into the challenges of recruitment and coordination of resources because of this complexity, because of a lot of new devices in these environments and domain expertise that's required. Recruitment is very challenging for IoT projects and edge computing, and especially the combination of IoT and edge computing projects. But little known, but certainly a factor in all this is sourcing parts of this overall solution. Over the last year, we've heard lots of complaints about delays in shipments of various IoT devices and edge computing devices. So even getting those devices delivered on time have been challenging in these times of COVID, but also equally challenging because factories, companies have all kinds of challenges in delivering bug-free and highly usable devices. And in the development environment, especially when you're talking about integration and development for at the edge and using IoT devices, the CI and CD processes are ones which are challenging to many companies, never mind the volume that's involved here with large numbers of devices and with all kinds of programming challenges, as well as the quality challenges that ultimately are involved with deployment. In this environment, there is a call for a low-code and automated design approach that can simplify and speed the deployment of these IoT and edge computing projects. And with that in mind, that concludes the slide portion of the show. Are there any questions?
Hey, Doug, we got a couple questions that came in. One was on how building automation and building IoT fits into your definition of the edge, BACnet specifically, but building automation generally.
Well, I mean, what that question is getting at is how does it all work together, right?
Yes, I assume so.
Well, the way it works together is, number one, their human resources are going to get it to work together. Finding the right people to staff these projects are in and of itself very challenging. Separately, however, putting together a plan and then implementing the plan so that all the goes intos fit together, and the inputs and the outputs all connect properly, and deliver the data to the users are, simply speaking, challenging. And then the deep technical challenges of customizing these IoT projects and edge computing projects, when they combine, is something that we are consistently hearing is a big challenge.
Okay, thanks. Another one just popped up regarding smart manufacturing. I'm going to read this. I see how a company can use edge devices to gather data for their own use within their own network. What about companies that provide edge-capable machines to that company? How does the machine provider provide analytic information and share machine data within the with the end user and satisfy network security issues?
Well, again, this is a mosaic of solutions, some of which are standalone, some of them are highly automated, and some of them are readily integrated, or some of them have to be customized in. Some edge computing machines are pre-programmed to function and I think the question was related to smart manufacturing. So there's a whole array of smart manufacturing edge computing devices which have been pre-programmed for manufacturing. And one of the ways to, the vendor oftentimes offers a consulting solution that tailors these devices to the manufacturing environment, or the IT department and the folks who are supporting the edge computing project have to customize those devices for the particular smart manufacturing plan. Fortunately, with clusters of manufacturing, located in various states in the US, there has arisen, a group of people who've developed expertise in customizing the edge computing devices to manufacturing. So we know of those companies located in, Indiana and Illinois and the Great Lakes states, et cetera. So you definitely need expertise and help in that integration of even the most automated and pre-programmed devices.
Okay.
I'm the question asker on that one. You have a lot of times the information from the machine has to do with the process being delivered by the machine that the supplier has the most expertise in interpreting. And so you have direct connectivity to the machines desirable from the supplier standpoint and beneficial to the end user. But that connection into a manufacturing facilities through their network is tricky. I've been kind of intrigued by Prescient's gateway and the cellular nature of it. So I hope we can address that later on a little bit. The ability to kind of break that one data stream without threatening the overall IT security of your customer. So anyway, my comment.
Well, it's a good comment. There is connectivity concerns, and you may separate, although it's integrated, the whole concerns about security. But there's also the whole issue of this, multi-level infrastructural integration, where even at the device level, you're mixing computing and networking devices with cellular and other communications devices. So one of the most challenging things is just simply finding people inside the company who can help make decisions in conjunction with outside experts to make all this stuff work together. This is one of the many subjects that are part of the white paper that you see here, time to value. And I mean, it's a very good question that I think is very consistent with what we're seeing out in the world.
It's a real pushback point with manufacturers when you try to do this.
I'm sorry, I missed the first part of the question.
I said there's a lot of pushback from manufacturers and companies, when IT departments, when you try to do this. And
absolutely. I mean, the manufacturers would rather throw it over the transom and hope that the companies can integrate it themselves or work in conjunction with consultants in order to do that. And in point of fact, this is one of the reasons why low code is so important, and why planning your infrastructure is so important, because essentially integrating these devices into not only a network and your security, but also connecting the data so that it goes to the right place at the right time, and many other considerations are a big part of making the project successful. And this is one of the reasons why it takes a while to do this, and manufacturers or vendor arrogance is part of the problem, just managing that.
Thank you.
Okay, thanks, Doug. We have a few more questions that we'll table for now, and we can hopefully address some of them at the end of the session. So we'll go from there.
Okay.
Great. So there's a lot of very good questions here. I think certainly if we wanted to cover it all, it'll take a while, but these are very exciting questions. So I will also touch on some of the answers through my section, which is more specifically about low code. Just following what Doug is saying, edge computing is something that's accelerating really, really fast. And if you think about, I would call IoT 1.0, where you have fairly dumb edge devices where you just periodically pull data from it, and you deal with the data in the cloud. IoT 2.0 is really about bringing that computing down to the edge devices themselves to save the data, save the latency. But now you have a lot of capabilities. You also have a lot of software complexity, right? So I think that's a problem we solve. How to reduce that software complexity for this type of edge computing systems. Before we go there, I wanted to give a broad picture of what low code is about for those who are not familiar with this space. So as you can see here, low code is rising really, really fast in the software application development industry. It's actually pretty astounding to see what has happened in the past 3 years or so, even in particular in the past year, where so many companies are adopting low code. There's a good reason for it. And you'll see it once we get to the slide to talk about the traditional software development complexity. So first, a very basic question: what is low code? If you think about full code, something we call, full code is about programming. And for an application, you have many, many files containing program code. The program code also needs to rely on programming languages, programming frameworks, which are typically, built in with the software themselves. So it's a very complex system, requires a lot of expertise. What low code tries to do is to remove that, to separate the application, which is what customers care about, from the technology behind it, right? So we show an example here. It's from one of the pretty well-known software low-code companies out there. And the solution is very simple. Graphical, drag and drop, And that's your application. The technology that runs that application, the technology that's behind the scene is invisible to the user who built this application. The user can build arbitrary applications. They own the application. They can do whatever they want with it. They can take it with them. That's very different from full code development. Full code development today, you have to put your program code together with the software framework in the same container. So you cannot separate the application from the technology. And in low code, that's one of the main advantages. And another thing is that, even though people have been talking about low code so much today, it's actually been around for, I would say, pretty much about 100 years. It's used everywhere, in particular in industries that are related to engineering. And the form is very similar. Is this graphical programming, functional block programming? It's pretty much the standard of what people do to systems where they deal with data. So the local benefits are pretty obvious. I think everybody understands that. First of all, first one, it makes things simple. Basically, you don't need all the technology expertise to build applications. It also brings in consistency, right? Because low code typically gives you fewer choices, which in some ways may be bad, but in many ways is actually good. It enforces that consistency among the applications that you design. And the modularity is very, very important, because now you can divide a large problem into small sections and tackle each one individually. It makes it easier to share solutions, makes it easier to understand the solutions. So there's many benefits that low code brings that full code makes it more complex to do. And low code users are not the same as those who do full code development, right? Full code development, typically you require developers. You actually require a fairly large set of developers today to develop a software application. In low code, you probably just need one or two to develop your full application. It's typically for IT engineers, OT engineers. OT stands for operational engineering, operational technology. It's for system integrators. It's for doing things that are fast, that are consistent. And of course, today, a lot of citizen developers are jumping into software in IoT, and low code helps that as well. So the big question is, why do enterprises care? Why do you need to care? Sure, low code is great, but what does that help me? There's a study recently by MIT Sloan and BCG that basically found that in the space of IoT and AI, on average, there's only about 11% successful rate in adoption. Here, the successful adoption definition is significant financial returns. So meaning that only 11% of companies are able to get significant financial returns from IoT and AI on average, right? So the key is that this is on average. But look what happens if a company enables something called organizational learning. Once that happens, the success rate, this is getting significant financial returns, is actually 73%. That's 3/4 of all the companies in this category. So what is organizational learning? Organizational learning is basically the way where the company has to work with the technology, has to integrate with the technology, and iterate over the solution. And once the company does that, the success rate is very, very high. The challenge, of course, today in IoT, AI, and even IT is the complexity of the technology. It makes organizational learning very, very difficult. So low code is really the best method to speed up that organizational learning. And I think if there's two slides that are the most critical ones in my session, it's this one and the next one. It's basically about looking at the full landscape of the frameworks that you can use to adopt IoT and AI, and even other digital transformation technologies, and decide what's the best for you. So obviously, the easiest to start with is a turnkey solution, right? You just buy it, you turn it on, it works. But you cannot program it, you cannot change it to expand it to do other things. So really solve some peripheral needs very quickly. That's what it does. No code and low code together form this middle tier. This is where you have programmability without a lot of complexity. But no code is almost like a programmable workflow, and it's usually constrained to a narrow space because of the constraint of the workflow type of programming. And low code, on the other hand, gives you some more ability to do more programming in a simple way. So it's much more widely applicable. And the full code, of course, is what typically technology companies uses to really optimize technology performance. So the question is, which is the best answer for you? Well, it depends. Obviously, if you can solve a problem with a turnkey solution, if it's a problem that you know what the outcome is from the start, and it's something that you don't want it to touch, you could buy it if it's available. And if you need more programmability, you go to either no code or low code. And for the stuff that's more complex, right? For example, if you're integrating IoT into your products, if you have a complex manufacturing process where you have many different places where you need to do monitoring and automation, low code tend to be more powerful and gives you that full spectrum of capabilities. Full code, I would say, typically is reserved to technology companies because it just requires so much investment and so much energy to build stuff in full code. And if you're building IoT product or IoT platform, certainly full code is the right answer. But even for technology companies, you wanted to consider what is the role of low code in your ecosystem. For example, if you're providing, say, an IoT platform for your customers may have a hard time to use coding to solve problems. So maybe low code should be part of your IoT platforms. And many IoT platforms today have that problem. It basically, in order to do anything slightly more complicated, you have to do a lot of coding in those. And that's hard for customers. And that slows down customer adoption. So let's look at an example. What exactly is low code? So if we look at this example, let's say there's application is a remote monitoring application. You're monitoring certain equipment or asset, right? And you wanted to be able to tell whether the equipment is down. You wanted to get log tables. You want the operator to be able to get alerts. So that's a very typical standard IoT application. And if you divide it into different components, there's three major components. There's a dashboard that usually the operator uses. There's a cloud application, which gathers all the data from the edge devices and does analytics, stores them in databases. And there's, of course, the edge application, right? Today, with edge computing, you can do machine vision. You can do very complex analytics directly at the edge. So you have to program all your devices. You have to be able to update all your devices. So there's three components. And how would we build this? Say, first in a traditional development environment. Well, you would have to use programming languages, typically very different programming languages for the three different components. But even harder, what's harder than the programming languages are the DevOps components, right? This is a component that enables the continuous development, continuous integration, the updates, the management, the scaling of your solution. It is very hard. In fact, this is what's pushing IoT, AI, and software development into low code, because every application today is a web application. And imagine for your IT engineer or OT engineer to build a web application, it is pretty much impossible. So low code enables them to build the actual application without worrying about all that technology behind the scene. So in low code, this is what the solution looks like. This is in our low code software, which is the first commercially available software to build the cloud application, the edge application, the dashboards, all together in a simple solution, right? So your engineers can just drag and drop components. They can wire them up. For example, they can deliver data from the cloud components into the edge components, from the edge components back into dashboards. They can directly program what happens in the edge devices or in the cloud, either through sort of drag and drop no code type of way, or a low code type of way. In fact, the platform is actually fairly flexible. Enables you to program in different ways to adapt to your engineering team, right? So on your engineering team, they may have junior engineers who are comfortable with drag and drop no code components and just do configurations on them. Or you have moderately experienced engineers who are able to do some coding within a controlled environment. Or you could have advanced engineers or developers who want to just go all the way. They just want to program away functionality. And you can do all that in our software. And that gives you flexibility and also gives you ability to hire different engineers to do different tasks. Another thing is that I think today, building an open ecosystem is very important. In fact, if you try to talk to some of the large organizations, rarely they would accept a solution that's closed. This is because today's software is built on open ecosystem. In fact, even if you buy a software that's proprietary, there are many open source components inside. And in the past, people think of open source as non-reliable. Today is no longer true. Open source, in fact, if you're using a framework, that's used by 98% of Fortune 500 companies, it is actually much, much more reliable because so many people use it. It's been deployed everywhere, and it's been tested and battle tested over and over again. So we leverage on this very popular open source ecosystem, but we build a lot of new capabilities on top so that it's an industrial grade solution. It's a distributed programmable solution. And I think as one of the audience commented, one thing that we can do is actually we can enable multiple parties to build those module solutions inside a low-code environment. Say if you're a hardware provider, you could build some drivers and solution sets that your customers can directly drag and drop into their solution, so that you can continue to update your solution recipe, and the customer would get those updates when they update their own system. So that's the multi-user, multi-party type of environment. It's very typical to some of the large local type of applications we've used engineering. So we have all that stuff built in there. And in terms of use cases, it's really for customers who are looking for programmability, for ability to evolve their solutions, right? So for example, we worked with a lot of equipment manufacturers and device manufacturers in the past pretty much 10 years, from some things as large as vending machines to something as small as those little e-ink displays. And what we've seen is that IoT, and today AI in particular, really brings transformative impacts to equipment and device manufacturers. This is because not only you're able to enable the remote visibility into your devices, remote control of your devices, but in fact, a lot of these hardware providers are turning into service providers. And this enables a new significant revenue stream. But this is something that you simply cannot just buy a peripheral IoT capability. This is something you really have to integrate very closely with your product team, and you have to evolve it. You have to improve it. But on the other hand, the benefit is absolutely worth it. There's another space, we call it the manufacturing space. That's a little bit different, but the reason you need it is because manufacturing is very customized, right? So you have all sorts of different functionalities you need in manufacturing, automation functionalities, and they are very different. They're different per each product you manufacture. So you need a programmable solution there. There's just no way around it. And the third one are companies, enterprises that are integrating IoT and AI to build competitive advantage. One example is, let's say if you're a insurance company, commercial insurance company, and if you can integrate this type of visibility, feedback, and AI with your fire protection system, you could possibly gain a competitive advantage over your competitors. This is not just sort of new revenue stream, right? This is basically, if you can protect buildings better, then you could potentially gain more customers. So those are all the spaces you can see. You need evolvement, you need development, but none of those type of companies are technology companies that specifically build IoT technology. So low code is the right answer for these industries. So another thing that we do is we build template solutions. Obviously, what we find is that a lot of customers, when they just get a empty canvas, right, in this low code software, it's hard for them to build solutions. So we provide a number of different turnkey solution templates, ranging from industrial automation type of templates to remote monitoring, machine vision type of templates. And so customers can just directly drag and drop the right template into the software and just get the right hardware. We have we support a number of hardware vendors, and they can deploy the actual solution on day one, and then they can improve that solution over time. So, we understand that there is a learning curve, even though what we typically say that if you're willing to take 2 weeks to learn how to use this, at least you can build the low code type of solutions. But we also wanted to help our customers to get through this learning curve. It's just like if you use RS Logics or LabVIEW, you do need to learn a little bit about it. But once you learn that, you get benefits from those type of software for years to come. So because of the constraint on time, I'm rushing a little bit. And I wanted to conclude this particular talk by saying that what we see is that IoT is really getting embedded in pretty much every product and every process today. A recent report by Microsoft says that 94% of businesses today are adopting IoT, and there's much more edge computing happening as compared to before, right? Previously, you were just getting dumb data periodically sent to the cloud. Today, that's no longer the case. And for that type, to handle that type of complexity, you want low code and other methods to contain that complexity. And finally, what I want to say is that IoT is very transformative. We've seen amazing results from some of the projects we worked on, but typically it requires a learning and iteration process. So that's challenging, but we have experience. I'm sure there's other companies that have a lot of experience that can work together to get through those challenges. So we do have a number of webinars coming up. So this one is more kind of business oriented, makes you think about low code, think about where the best uses are. The next one is going to be technology oriented. Is really going to be how Prescient Designer works, how to design things in it, how to work with partners in Prescient Designer. And in particular, if you have users who are familiar with Node-RED, you can easily integrate your existing Node-RED solutions and templates into Prescient Designer. So we welcome them to listen to how to do that. And there's another webinar coming up in March. It's about organizational learning. It's about basically how to efficiently learn and iterate over IoT and AI to produce the best successful adoption. So please go to the link at the bottom to sign up for announcements of these events. So I will stop right here, and I think we have maybe 5 minutes for questions.
Sure. Andy, there was an earlier question about in the future what a revenue model might look like for distributed data prediction. So just revenue models in general might be interesting to talk about.
Yeah, this is a really interesting question because things are changing very fast, right? So, today there's only two players when you are talking about IoT solutions. There's IoT partner, right, who provides a technology platform. Then there is the IoT customer who, uses it and possibly can sell it to their customers as a subscription model. So that's pretty straightforward. But today there's also other companies that are in the landscape, right? So for example, in IoT solution, you need very good hardware. You need very good analytics. You now probably need some AI capabilities. So there is a lot of party involved, and what we're doing from our side is build this type of shared ecosystem type of idea where basically if you are, say, a hardware provider or analytics provider, you can insert your solution into the platform and get paid for them that way. We're still early in this though. Most of the projects we do it on our own, but now we're actually reaching out to a lot of companies that possibly could provide part of the solution inside it. So we really welcome conversations with potential partners on this and figure out what's the best way to handle this type of revenue model. It's a very, I think it's a very interesting and very exciting thing to figure out for the next few years.
Okay, I know you touched on the open source standards and such. There was a more specific question about industry consortia and standards. If there's anything you didn't address that was noteworthy earlier, there was a question about that.
Right. So personally, I have mixed feelings about standards. I've been involved in a number of standards committees, and standards are good when they are able to regulate kind of the format and the way that people can plug solutions together. But if standards gets bloated, usually it also limits what you can do. Today, I think things are changing today. I think today there's a lot of open source type of ecosystems that are basically standards, but it gives you a lot of freedom to do things. On the other hand, that's not enough, right? As we all know. So there also needs to be regulations, things like that, to make sure things are interoperable. What we do, I think one of the things people are converging on is basically the data format, right? So for example, the data format is very much majority of companies use a JSON type of format. This is a specific data structure that's very flexible, very easy. And as long as you support that type of data structure, you can support many systems. So JSON is at the core of our system, right? From the time when the data comes into the edge device, it's in JSON, and it propagates through JSON. And you can format it very easily along the way. You can work with other systems, but you can also convert it into other data formats very easily as well. So I think the industry does need more standards, but I don't see it happening anytime soon because there's so much development and acceleration, and that makes coming up with a universal standard difficult.
Okay. The only remaining question was one going back to Doug's presentation about optimization. It was on a particular slide number 9, which I don't have in front of me, but about whether it happens at the edge or whether it could happen in the fog or cloud as well.
Doug, do you want to take on this one?
Yeah.
Well, so the question is, as I think I understand it, is where does optimization occur, at the edge or in the cloud? And the answer is, in order for optimization to occur, data has to be fully analyzed, and then and increasingly that is occurring at the edge. So in this smart manufacturing example, you know, the guy or the woman in the lower left-hand corner could be doing some analysis, but this would be optimized perhaps in another edge location. So let's say this smart manufacturing facility was in Michigan, and the analysis was being done in, you know, in Boston, and then shipped out to headquarters location in California. So when, you know, the edge is sort of, it functions as a word in two different ways. This smart manufacturing facility, if it's all, you know, connected in one location, is one edge computing project. But the edge also means that other locations on the edge may be talking to one another and exchanging data. Manufacturing optimization can occur either in one edge location or multiple edge locations. And I think it's the role of data science and analytics and BI to really merge all the analytics and get some analytical answers for use in, you know, in these applications. And I'll leave it at that. I could go on forever.
Yeah, so following what Doug is saying, part of the answer depends on what capabilities you are using. For example, you could have microcontrollers or CPU-based edge devices or even GPU-based edge devices. Depends on the power consumption, the cost. You can do things from very simple things to very complex things. And you know, this is why I also wanted to encourage you to attend our next seminar. This is because you can see that in our software, you can just drag and drop a computing function from the cloud into the edge or into a different location. So sometimes you have to experiment, you know, to see where's the best place to do that. And in a low code, the type of platform like ours, it's basically drag and drop. The same, say, data analytics function, you know, that you used to do in the cloud. You know, it's a module, just drop it, drag and drop it into the edge to see if it works better. So that ability for experimentation is what a low-code software offers. So with that, I think, you know, we will conclude. Thank you all so much for attending. If you have any questions, please contact us. My email is just andy.wan@prescientdevices.com. Please feel free to reach out. We're happy to talk. We're happy to send you, you know, trial software. And generally, we love to learn about the different things you're doing, because that helps all of us to do better and to help IoT to adopt faster in the industry. So thank you very much for attending our webinar.